All right, we'll get going in like 10 seconds. So, can someone in the Zoom tell me if they can hear me? I'll take that as a yes. Cool, they can in fact hear me. Okay. Don't need VS Code. All right. Yeah, okay, so let's get started then. This is, I believe, the final lecture of the decal for this semester. Hopefully we'll bring it back next time, but you've all seen various aspects of AWS before. So this includes things like compute services like EC2, function as a service, like Lambda, as well as a whole host of other stuff, right? Now, I want to talk today about some more applications of everything you've been learning in this. And I don't think there's a better place to look for applied use cases than Cloud@Cal's dev branch. So I am the leader of Cloud@Cal's dev branch, and I'm going to give you guys an overview today of 5 current and past projects that we have done. So 3 projects we've done right now, and 2 projects we've done in past semesters. So how I want this to work is I'll talk a bit about a particular project, and then you guys can just ask me any questions about that project. And we'll do this for all 5. And at the end, I'm just going to turn it over to you guys and make it like an Ask Me Anything. So without further ado, let's get going. Yes, this is a set of clients we've had currently and in the past. So the first one I'd like to talk about is DLab. So what DLab is it's a service provided by the university, and it's used mainly by people who are technical or in the humanities or the social sciences and trying to use more computational resources. A lot of fields are becoming more data-driven now, and as a result, the demand for computational tools is increasing. DLab attempts to meet that demand. So basically, what we wanted to do for DLab was build them a custom Jupyter Hub. So who here has used Jupyter Hub before? Yeah, so a couple people have. Now, one of the amazing things about Jupyter Hub is it provides you a kind of clean Python environment to run any projects you want to. It can also be adapted for use in languages such as that a lot of social scientists love for some reason. I have no idea why, but they just like it. It's dog slow, even slower than Python, but I guess we'll let them be them. But the problem with Jupyter Hub is it's great to run locally. However, one of the weaknesses is that it's not easy to share your files with other people. When you're in a research team and you want concurrent and you want consistent data sets between every member of your team, this is where it starts to be a problem. So what we wanted to build was a custom Jupyter Hub that allowed file sharing. Now, let's get into the tech stack we use for this. So our expectation was that a team of researchers could visit a particular URL and access their Jupyter Hub. And by that, I mean, we had to make an authentication system to let them be able to log in. We also had to have a mechanism for storing files and handling access controls. So the solution here was actually pretty simple. In order to host our custom Jupyter Hub, we used Amazon EKS, Elastic Kubernetes Service. Now, how many people here have used Kubernetes or have heard of Kubernetes before? Okay, so a bit iffy. Okay. So for a brief explanation of Kubernetes, nowadays we run, when we actually run apps in production, we use containers. So containers are a form of virtualization where we provide software abstractions for pretty much everything but hardware. This is in contrast to a virtual machine, which virtualizes everything, including the hardware. So public containerization services include things like Docker, which we had to use as well in order to actually roll up all the dependencies we wanted for a custom Jupyter Hub. What Kubernetes does for us is it's a container orchestration service, meaning it can help us manipulate containers. It can help us link containers to each other. and it can help us expose containers to the outside world. So Kubernetes was useful for that. We use Amazon's EKS. For file storage, we just use S3, partially because we just want to keep this as simple as possible, and because S3 already has a lot of access control features built into it. And additionally, IAM, which we can use for access control, is very easy to configure. We used Lambda to do some stuff in authentication, and we used some customized. We also used some very heavily customizable pre-built Jupyter Hub distributions in order to actually get the core capabilities of Jupyter Hub. The distribution we ended up going with was called the Littlest Jupyter Hub. Now, you might think that this is kind of like a toy example of Jupyter Hub, but it's actually not. The documentation suggests that it's actually best for groups of under 20 people because it uses a single virtual machine. Now, we also tried the classic Jupyter Hub distribution as well. We found out that that was a bit more suited for large-scale applications because it was more distributed across machines rather than sharing a single virtual machine for everyone. And this is where the file sharing aspects that we got from S3 and from EKS came in handy quite a bit. Now, does anyone have any questions about this project? Anyone on Zoom want to speak up if you got a question? I'll take that as a sign to move on. So the next project we have is Study Squirrel. So Study Squirrel is actually a Berkeley-based edtech startup. So who here has used Chegg? Yeah. Chegg, what else is there? Course Hero. Yeah, it's kind of like Chegg, Course Hero, and like half of LibGen rolled into one. It's kind of like a site where people from different universities can sign up and pretty much share their notes, etc., etc. Right? So what we did for them was the following. They were a very early stage startup when we. So basically, long story short, when we initially started working with them, they did not have their stuff together. For example, they weren't doing things like taking backups of their databases. They had like a very messy Terraform setup that they'd hired a consultant to do. As a result, they actually knew very little about their own systems. So our task was to kind of bring some order to the chaos. And this came in the form of multiple things. So first of all, building a local Kubernetes environment for them to test in, because at that time, their development workflow was just running stuff in dev, not really testing much, and then just pushing directly to production. Now, that is not something you should do ever. You need a dev environment or a testing environment to actually play around and make sure you don't break production. And as a result, they had very, very bad availability. So we talked about availability a bit at the very start of this decal, where we just measure kind of uptime or the percentage of service or the percentage of time your service is available to operate. Normally, we expect at least like 99%. And even then, nowadays, that's considered pretty shambolic. But for an early stage startup, the expectation might be a little bit lower. In any case, we had to build for them a local testing environment, as well as doing tasks like setting up log-based alerts to tell them when their Kubernetes cluster was being overutilized, and also automating database backups for their MongoDB setup. So kind of predictably, our stack includes Docker and Kubernetes. In particular, this was done on GCP using the Google Kubernetes engine. And we also use services like Docker, MongoDB, and Terraform. So how many people here have heard of Terraform? A bit, okay. So Terraform comes from a concept called infrastructure as code. So a lot of the time, well, before infrastructure as code was around, you basically had to either get your own servers, configure them yourself. But obviously, this is the entire cloud concept. We don't want to do that. We want to have these abstractions that, hey, this is a server, we can scale it to our needs, and we can run whatever software we want on it. Right, but even then, it's still kind of intimidating to go around and go on, say, an infinitely configurable console and then try to find exactly the right settings that work for you. Now, infrastructure as code simplifies this concept a bit because you can use kind of markup languages like JSON or YAML to actually specify how each component of your infrastructure setup should work. Now, Terraform is very versatile. It's a pretty commonly used tool, and it's also compatible with a great many cloud providers. For example, you can set up AWS services with it. You can set up Azure services with it. You can also set up Google Cloud services with it. And yeah, Terraform works. If there's two main things you should know about Terraform, it's that it kind of has it's kind of a system like Git to stage and apply changes. Now, you have a command called Terraform apply, which is kind of like Git push. This actually takes whatever changes you have locally and pushes them directly to production or directly to whatever environment you're running it in. There's also a command called Terraform plan. Terraform plan is kind of like Git diff in that it shows you what changes you're going to make to what components. Now, the golden rule of using Terraform is always run Terraform plan before you run Terraform apply. We learned this the hard way. Additionally, we had to help out with some kind of more day-to-day maintenance stuff. For example, these guys used to be called scholarhub.us. But when they changed their domain to studiesquirrel.com, they ended up inadvertently taking down their whole website because their Kubernetes cluster was not set up to track the right IP address. They got a new domain that they registered in Route 53. Route 53 is an AWS domain name service. And from that domain name service, you can obtain what's called an A record. And the A record will contain kind of the external IP that you need to access in order to get to that site. You need to configure Kubernetes with something called an, what I believe is called an egress that actually allows your Kubernetes cluster to be exposed to the internet. So we had to help them do that. Additionally, we set up a cron job. So a cron job is just basically, think about it as like a script that runs on a schedule. We set up a cron job to automate their MongoDB backups because previously they were not backing up the database at all. And obviously, this is not something you should do. When you see a lot of these data storage services, they will explicitly advertise about how well your service is backed up, or how they have distributed backups or distributed copies of your data. And this is kind of a concept called dependability via redundancy, where you store multiple copies of something you want to keep safe. So, for example, if one piece of storage is compromised, then you're not screwed. You can still recover your data in some other way. They didn't have any of this, so we just automated a MongoDB database backup for them. Additionally, what my biggest takeaway from this project was how to do incident response effectively. Their setup was done by a consultant that they'd hired. And as a result, the two people who were actually running Study Squirrel at the time knew very little about how their own setup worked. Didn't really know much about Kubernetes, didn't really know much about how their Terraform setup worked. Really, all they could do was front-end development. So as a result, their site went down quite a lot. And we had to work to bring it back up again. So that was not exactly the happiest experience I've ever had. It's not exactly the it's not exactly the least stressful thing I've ever done, but it's faithful to what will happen if you follow bad software engineering practices. So my advice to you is, in all software engineering, look before you leap, run Terraform plan before you Terraform apply, and please back up your data. I implore you to back up your data and always have access control or protect whatever it is that's running in production. So does anyone have any questions about this? No questions? Anyone in Zoom? Anyone on Zoom, just feel free to speak up if you have questions. Okay, in that case, I'll move on to the next project. This one is slightly more exciting than Study Squirrel. It's gaming analytics. So gaming analytics is the first client I'm going to talk about today that we are currently working with. Now, they're based in Novato, and they're a casino analytics company. So what they do is they make various tools for casino managers to see how different aspects of their casino are doing. So the project is built upon the assumption that casino managers are stupid and don't want to learn SQL. Right? Like, how many people have used SQL here before? Yes, pretty much everyone. Yeah, SQL is not, SQL is one of these declarative languages. So declarative means that you specify what you want to get back, but you don't specify how the computer system actually gets it for you. So this is actually done via a very interesting process called query optimization. So basically, how many people have heard of joins in SQL? Okay. So basically a join is what happens when you've got two tables and you want information from those two tables combined. Now, in database systems, you want to minimize what are called IOs. So this is built on top of a concept called memory hierarchy, right? So for example, on the CPU, you have registers. Registers are very small. They can store like one machine word each, and depending on your system, that's like 32 bits or 64 bits. These are very fast, but also very expensive. And the trend is, as you get larger, as your storage gets larger, it also gets slower to access, but it gets a lot cheaper. Like I can go to Fry's. Well, I was going to say Fry's, but Fry's doesn't exist anymore. But you can go to a lot of stores nowadays and get terabyte hard drives for not an exorbitant cost. But per byte, registers are still going to be a lot more, say, expensive than buying disk storage. Now, a lot of the time, your database is not going to be small enough to fit into main memory. So you're going to have to bring up what are called pages. These are just fixed size units of memory from a lower level in memory hierarchy, so cheaper and larger, but also slower. And you're going to have to bring it up into main memory for faster access. Now, you want to minimize the number of these IOs you do, and IO is when we bring up a single page into main memory, because the IOs kind of trump any other computational cost that exists in your database. That's why we count in terms of IOs when we're actually optimizing a query. So the query optimizer will figure out not exactly optimal, but it'll figure out a near optimal way to organize the operators on tables such that you minimize the number of IOs that the query actually expends. Now, let's digress back to gaming analytics from that brief rant into SQL. But yeah, what these guys do is they build an NLP engine to where, say, a casino manager can type in a natural language query and get back statistics about their casino. You can think about it as just Google, but for casino statistics. So for example, a query could include, give me all the money I earned, or give me the amount of money I earned from casinos that are located in Las Vegas, or give me the amount of money earned from slot machines, or the amount earned from poker tables, or something like that. This has a lot of very practical use cases for, well, if you are a casino manager. Now, the weakness of their current NLP engine was the following. There can be ambiguity in some of these terms. So for example, one of the weaknesses they had was on dates. So if I was to say, give me all the money I earned from casinos in Las Vegas, it might not have detected that Las Vegas is actually a city, a location that I want to analyze. But if you said, give me the money I earned from casinos in city Las Vegas, then it would get that. It relied a lot on hints. Additionally, ambiguity played a role here, partially because you can actually search by player name in their existing engine. So is anyone here called Austin by any chance? No? Well, you can say, one of the queries you could make here was, give me all the money I earned from casinos in Austin. Now, this could mean Austin, Texas, But if there was a player named Austin, then it could well get confused and say, okay, this is all the money that player Austin won. Now, this was effectively an NLP project. And to that end, we used various NLP models, including BERT and GPT-NEO. So how many people here have heard of GPT-3? Yeah, GPT-3 is one of the most revolutionary language models that's come out in recent years. However, it doesn't work very well without a lot of computational power at your disposal. So to combat this problem, what the team did was they used GPT-NEO. GPT-NEO is kind of a smaller version of GPT-3 or GPT-2 that is designed to run well when you have limited computational resources. Now, we didn't want to pay out of pocket for a bunch of like GPUs on SageMaker or something else, so we ended up using Colab's free GPU. We also used Spatie. How many people here have heard of Spatie? But yeah, Spatie is effectively providing a suite of pre-built NLP tools. So it helped a lot for the use case for dates. And how many people here have heard of BERT? Okay. So the core concept behind BERT is the following. So you can't just give an NLP model words and expect them to like work with text directly. You need to translate this into something more mathematical, right? And for this, we have the concept of a word embedding. So word embedding is just a vector that you obtain by training a model on some kind of corpus. Now, in kind of the early days of word embeddings, these were deterministic. So you train these on a corpus, and what would happen is every word would get the same vector. But in NLP, you have this problem called polysyny. And this means that different meanings can be assigned to the same word. For example, running a marathon is very different from running a company. However, in a deterministic model, those two meanings for the word running would be assigned to the same vector. Now, we then had unidirectional embeddings. So it could take into context, it could take in not only the current word, but also the word to like one direction of it, and effectively incorporate that into the word embedding. So now you no longer have a deterministic word embedding, but you have a contextual word embedding. Now what BERT does here is twofold. BERT is bidirectional encoder representation with transformers. So as the name implies, it has bidirectional context. So it considers both the tokens on the left and the right. And its training procedure is quite unique because it takes in a corpus and randomly masks 15% of the tokens in that corpus. And BERT's training objective is to fill these masks. So this leads to a model that can consider bidirectional context. And from the layers of the neural network that BERT is constructed from, you can extract a contextual embedding. Now, this is commonly done by summing or concatenating the values in the layers of the neural network. There's a bunch of very interesting demos that actually use a PyTorch-based version of BERT and actually construct these contextual embeddings. If you have any questions, please, please ask. So are there any questions about gaming analytics? No, they're not. Well, some of them can be considered like that. For example, Colab. The way that it gives you access to a GPU is kind of similar in the way that, say, EC2 would give you access to more compute resources. But there's also an element of using kind of tried and tested tools in NLP to actually accomplish an NER task. So how many people have heard of an NER task, named entity recognition? Okay, yeah, okay, so a couple, okay. Named entity recognition is basically when you have a bunch of tokens you want to classify, and pretty much various groups you want to put them into. So in the case of gaming analytics, it would be, for example, date, or like game type, or manufacturer. Because you might imagine that, hey, if a particular manufacturer's slot machines are paying out more than another manufacturer, then hey, I'm going to stop using the manufacturer whose machines are making me lose more money. things like that. That's the use case of NER here. And that's why we're interested in this problem. BERT is, the thing is, BERT is never really used as like a pure word embedding solution. BERT, the good thing about BERT is that you can fine tune it a lot. So in the original BERT paper, they'd actually, fine tuned question answering on what's called on data set called the SQUAD data set, Stanford question answering data set. It's also been fine tuned to do things like binary classification. It's also been fine tuned for like multi-class classification. It's been fine tuned for NER as well. There's also various different ways of prompting BERT. There's also a task called mass language modeling, which you can do with it. So mass language modeling is literally just the task of filling in the blank, as I mentioned earlier, where you can apply a mask over an arbitrary token in a sentence that you give to BERT, and BERT will output like a list of words and probabilities for each. BERT is never really used explicitly as a word embedding solution, but it can be used, it can be fine-tuned for a wide variety of NLP tasks. But the point here is that BERT is going to consider bidirectional context, and a word embedding can be extracted from BERT using its neural network. So does anyone have any more questions about gaming analytics or just any of the technologies we've used here? All right, in that case, we'll move on. Next is Grabengo. So Grabengo is a project that's pretty dear to me because I'm the one who was leading this. Grabengo is a local frictionless checkout company. Their headquarters is literally a block away from the western edge of campus. But what they do is they manufacture this hardware that's called a G-Rail. And a G-Rail is effectively like ceiling mounted, like a light fixture. But what it has is a bunch of cameras and hardware that track a customer's movements within a store. And the goal is twofold. First, you want frictionless checkout. And this can be accomplished by tracking what products that customers take off the shelf. And secondly, they want to give these stores, so for example, they're working with gas stations such as Circle K and BP. They want to give these stores the ability to harvest consumer behavior data and apply it to actual insights in the store. For example, if I buy milk, am I more likely to go buy bread afterwards? Or for example, how do particular displays impact customer buying behavior? It's questions like those that stores can use this consumer behavior data from the G-Rails to answer. Now, what we built for them was a system for failure analysis. Now, Grabengo has a huge computer vision team, and they use computer vision to determine, given the camera image or whatever the camera from the G-Rail is observing at a moment in time, draw a bounding box around the product that a customer is buying, and then classify whatever is in that bounding box. And in the end, you want to end up with a UPC, a universal product code, to determine what the customer actually bought or took off the shelf. Now, for this failure analysis tool, we built this on GCP as well. So, unsurprisingly, we use BigQuery. So BigQuery is what's called a data warehouse. So you can still query it using SQL, but it provides many of the capabilities that a database does, in that you can still extract records, you can run things like joins on it, et cetera, et cetera. Right now, what we used as our front end was a technology called Streamlit. So Streamlit is kind of an unorthodox choice for building front ends in Python. A lot of people might use something like Django, which is a full stack web framework. But for our purposes, what we want to do is provide just a clean user interface where Grabengo's engineers could interact with various records from a table of results that they stored from their CV APIs. So we use Streamlit to make our front end because it has a very robust set of features that you can use that's built into the library. And it also gives you flexibility to add in your own features. So how Streamlit works is that you can specify a script. And how many people here have used React? Okay, so a few people have used React. So a lot of time in React, you need to actually render your components. Now, Streamlit does this by simply rerunning the script over and over. And you can specify on what events you want to re-render your web page. So Streamlit is actually quite a good library if you're trying to move fast and build a front end. It's also very, I don't think it's very popular, but at least semi-popular among data scientists, because it offers them a quick way of building data visualizations, because it has good integrations with things like Matplotlib. And obviously, we've used OpenCV to do things like image manipulation and warping, and also drawing things like bounding boxes and event locations. So does anyone have any questions about this project or the tools we've used? In a way, so from the point of the user, there isn't really much of a difference between BigQuery, like a data warehouse, and just a regular database, because you can still query it with SQL, or basically get any of the results you would from an old database. However, a data warehouse is designed a bit more for large-scale storage, whereas the database is effectively just designed to be queried. For example, there are a lot of databases that are just designed to fit in memory. And I talked about the IO concept before. If your database and everything associated with it can just fit in memory, then you don't have any IOs. You can just compute on it right where it is in memory. A data warehouse is more suited for these kind of large-scale data storage solutions. Anyone else? All right, then in that case, we'll move on to the last project, which is SkyGenie. So SkyGenie is based in San Jose, and they're a sales intelligence company. So their value prop is based on something called the Pareto principle. So has anyone heard of the Pareto principle? Yeah, 80% of consequences are caused by 20% of actors. Now, this is true very much in sales organizations, where you might have one or two sales reps that are carrying your company, and 80% that are just not carrying your company. And then what every sales manager wants to do is get the most out of that 80%. So what can the underperforming reps learn from the top sales reps? And for this use case, they work with clients and build out custom dashboards where someone like a sales manager or a chief revenue officer can come and take a look at what the top reps are doing right, what the bottom reps are doing, and compare and contrast them. Additionally, this requires a lot of third-party integrations. So connecting to APIs that clients use to track their sales reps. So for example, things like Gong, which relates to phone conversations. So this was built on Azure, mainly in libraries called D3.js and also in Node. So how many people have heard of D3.js before, just out of curiosity? Yeah. Okay, so D3.js is built kind of on top of React. It's used to make kind of front-end visualizations for React, in particular, stuff like pie charts, bar charts, etc., that someone from a business context would be interested in. Additionally, we interface with all of the APIs provided by the clients using Node on the backend, and using various Azure services like the Azure Kubernetes service to actually serve containers, and things like Azure Functions to actually run jobs on a periodic basis. So does anyone have any questions about this? There's a surprising amount that you can learn from a top sales rep. So, for example, you see a lot of underperforming sales reps that try to go for like a lot of small deals. But you can also see that a lot of top performing sales reps and a lot of companies, they tend to do what's called whale hunting. And by that, I mean, every quarter, they only close very few deals, but those deals are huge. So those differences in the pipeline of like who you pursue, that definitely makes a difference. Additionally, you've got things like Gong, as I mentioned. Now, you mentioned Charisma. Gong, it records phone calls. That's a great way of like quantifying charisma. So if a company has access to that, they can use it to compare between their top and underperforming sales reps. Additionally, lead sourcing is very big in this space. So you have got people called account managers that go and source leads. So people who you might sell to. And actually, we found out that in some companies, where the lead comes from is actually a very, very good indicator of how likely the deal is to close. And this actually has worked. Clients have reported like revenue increases up to 20% after using SkyGenie. This wasn't our choice. Basically, the co-founders were working with a dev team in India. They'd initially built stuff on AWS. And in fact, the CTO admitted to me that AWS is a better stack than Azure. But it turned out that their devs in India were a lot more familiar with Azure as opposed to AWS. So they just ended up porting their entire platform to Azure and using it. Any more questions? Don't be shy. Yeah, so with that, I guess I'll turn over the floor to you guys. If you have any questions about anything I've said or like about Cloud at Cal in general, or about how to become a dev in Cloud at Cal, feel free to ask. Yeah, I'll be here for some time. With that, there's the QR code as the password. Yeah. Hopefully we can get this. Oh yeah, I'll just leave that there. Hopefully we can get better attendance next semester. If there is a next semester. And yeah, have a good rest of your week. Have a good dead week and good luck with your finals. So that's it.
Hi, I have a question about the final project.
Sure.
So for the short video to submit via the because, and so what we should do is just introduce some functionality of the project or some details about how to implement the project.
Are you talking about the final project?
Yeah, so I think
Yeah,
it should be just maybe outline the basic functionality for the project.
Yeah, I'm not too familiar with how that's going to work. I think Bowen is the right person to ask for that.
Oh, okay, thank you.
Add it on the Ed, and someone should respond.
Okay, yeah. So as Shrita said, you can add it on Ed. Didn't know we had Ed.
Yeah.
Anyone else got any questions in person or on Zoom?
Hello?
Does anyone else have any questions?
Can you hear me?
Oh, yeah, I've got one question first. We'll handle that and then I'll come to you. Yeah. The thing is, we can't open source really anything we do because when we work with a company, we have to sign an NDA. So like we can't, well, actually, NDA and CIIA, meaning like not only can I not disclose anything I found there, but I also can't start a competing business for a period of time. So yeah, too bad for me if I want to start a competing frictionless checkout business. So yeah, there's a question on Zoom.
Yeah, I had a quick question about the gambling analytics one, the gaming one.
Sure.
Yeah. Why did you? It was just curious, but why did you guys go through the trouble of like setting up a whole like NLP stuff thing when or rather like was was your use case like you needed something more complicated, like just like a good search filter for like the managers to like kind of fill in the blank? I want location from X and then date ranging from Y,
That's
and
what's very
then
much
just
the-
like
Oh, sorry, go
just
ahead.
like converting that into a query instead of doing the NLP and trying to interpret like a full like sentence.
The thing is, it was very much improving upon an existing search engine. Their
Oh,
problem
I see.
right now is, well, their selling point is that you can enter a natural language query, like as you want to, and then get whatever statistics back that you want. So that was kind of the conflict we're operating under, meaning we had to go to the same trouble they did of implementing an NLP engine. Any other questions? All right, yeah, I'll take that as a no. Yeah, so I'll end the recording here. And then, yeah, I'll be in the Zoom meeting for a while after. So if you still have any questions, feel free to ask.